billion years ago when, in our corner of the galaxy, planet one among billions began to form around a young star. First, it was nothing more than a ball of liquid metal and rock, intensely bombarded by asteroids of all sizes. Its surface was covered with molten rock, rivers of lava, and erupting volcanoes. The planet's geography changed rapidly as it developed an internal structure and altered its appearance under the relentless bombardment. Its atmosphere consisted of toxic gases with almost no trace of oxygen, making it uninhabitable for any conceivable life form. This was the Hadean, the first eon of Earth's history. Though it lasted for 500 million years, it eventually came to an end 4 billion years ago. The bombardment slowed down, the crust thickened and solidified as the planet cooled, and this primordial hellscape became quieter. A new eon began, the Archean. Continents formed, though they looked vastly different from today. Between them, vast oceans of liquid water appeared. The atmosphere remained nearly devoid of oxygen, and the land was barren, no plants, no animals, no witnesses to the planet's violent geological activity. The Archean lasted an unimaginable 1.5 billion years, 3 times longer than the Hadean. But during this time, something extraordinary happened. In shallow waters near the coast or where the ocean floor was close to the surface, life appeared. Nothing spectacular, just colonies of microorganisms forming microbial mats. But these primitive organisms introduced a revolutionary process, photosynthesis. Using sunlight to fuel chemical reactions, they released free oxygen into the environment. For hundreds of millions of years, Earth's vast oceans absorbed this oxygen, keeping the atmosphere oxygen-free. But eventually, the water became saturated and oxygen began accumulating in the air. For 1.5 billion years, the Archean ended and a new eon began, one that would last for 2 billion years, the Proterozoic, meaning earlier life. During this time, another miracle took place. Until then, life had consisted only of single-celled organisms. But multicellular organisms began to emerge. Perhaps they had existed earlier, but now they multiplied exponentially. Though still microscopic, they were several times larger than their predecessors. They continued transforming the oceans and atmosphere by releasing more oxygen. During these 2 billion years, Earth's continents drifted, its appearance changed, and its climate fluctuated. At times, the planet may have been entirely frozen, resembling a snowball hurtling through space. Still, there were no land plants or animals. But in the seas, by the end of this eon, the first soft-bodied animals had started to colonize the waters. We are now 540 million years in the past. We have already covered nearly 90% of Earth's history. A new eon was about to begin, the Phanerozoic, the age of abundant plant and animal life. But this abundance came with fluctuations. Several times, life flourished and diversified, only to be devastated by catastrophic events, intense volcanism, drastic climate changes, asteroid impacts. Mass extinctions wiped out many species, setting life back significantly. But each time, it recovered. These cycles of expansion and collapse define the eras of the Phanerozoic, which are further divided into periods: Cambrian, Ordovician, Carboniferous, Triassic, Jurassic, and Cretaceous are among the 12 major periods identified. Each spans tens of millions of years and contains even shorter epochs. Finally, 2.6 million years ago, almost yesterday on the scale of 4.5 billion years, one of these periods, the Neogene, ended in a glaciation event marking the beginning of the Quaternary period. This is our period. First epoch of the Quaternary, the Pleistocene, is also called the Ice Age, because it was marked by multiple glaciations, periods of ice sheet expansion, and retreat over the continents. But despite the ice, life thrived. Species evolved rapidly, including the genus Homo *, to which we belong. Over time, one of its species, Homo sapiens, became the dominant force in shaping the world. This ice age, the Pleistocene, ended less than 12,000 years ago, transitioning into a warmer epoch, the Holocene, which we now live in. But tonight, we will explore what Earth was like during the Ice Age. Who and what lived on it? What do we know or suppose about the animals that roamed the lands and seas? Yes, there were saber-toothed tigers, but also lesser-known creatures. I will tell you about the rise and diversification of archaic humans and the evolution of our species. This field of study is constantly evolving, with new discoveries reshaping our understanding of the past. Remember, most of what we discuss tonight remains theoretical, supported by paleontology, archaeology, geology, climate science, and logical reasoning, but still theories. Before Before we begin, take a moment to focus on your breathing. Release the tension in your shoulders and limbs. This talk is meant to accompany you whether you want to relax or fall asleep. There is no need to listen to it all in one go. You can use the timestamps in the description to navigate between chapters or return later. The timestamps are also in the pinned comment, along with links to audio streaming platforms like Spotify and Apple Music if you prefer to listen there. You'll also find a link to my Patreon page where you can support this channel. Thanks to my patrons, you won't be interrupted by ads before, during, or after this story. Becoming a patron allows you to download all stories easily, participate in surveys, receive updates, and enjoy everything as a podcast. If you feel inspired to join and contribute to keeping this channel alive, you are more than welcome. Now that we're all set, let's begin. What was Earth like during the Ice Age? 2.5 million years ago, the world's continents looked surprisingly similar to today. Over tens or hundreds of millions of years, land masses shift dramatically as continents drift apart or collide. But on the scale of just a few million years, these changes are subtle. However, glaciation altered the planet's appearance in other ways. Massive ice sheets covered vast regions, locking up enormous amounts of water and causing sea levels to drop sometimes by as much as 100 meters, 300 feet. This meant many of today's islands were connected to continents by land bridges. For instance, North America and Asia were linked by the Bering Land Bridge, allowing animals and humans to migrate between them. Glaciation also maintained frigid climates along the edges of the ice sheets. In North America, just south of the glaciers, lay a vast permafrost zone, an area where the ground remained frozen year-round. In Eurasia, particularly in Siberia, this permafrost extended even farther. These frozen landscapes are valuable to scientists today because they preserve entire specimens of extinct Ice Age creatures, allowing us to study them in remarkable detail. By analyzing ice cores extracted from glaciers, scientists can determine past atmospheric conditions including levels of carbon dioxide and other gases. These records show that glaciation cycles occurred approximately every 40,000 to 100,000 years, punctuated by shorter interglacial periods lasting 10,000 to 15,000 years. When the climate resembled today's, these repeated climate shifts had a massive impact on plants, animals, and early humans. In fact, midway through the Ice Age, something changed. Glaciations, which had previously occurred every 40,000 years, shifted to a longer cycle of 100,000 years with more extreme cooling. This shift reshaped ecosystems and drove evolution in new directions, including the emergence of Homo sapiens, the species that would eventually dominate the planet. So, what was the world like? What kinds of animals roamed the land? How did early humans survive? Tonight, we'll explore these questions in detail, but for now, relax, take a deep breath, and let the journey begin.